All right, we're picking up with Unit 1.6, Objective number 2. We talked about relations in our last lesson as a set of ordered pairs, and we're going to look at these both in the familiar now ordered pair format, as well as tables, graphs, and mappings. All right, so in our ordered pair, we can just do a list of ordered pairs just as a list of points. So I could say the point 2, 3, and the point 2, 5, and the point 3, 5, and the point 3, 8. Let's say the point 4, 7, and the point 6, 10. So I could just list by ordered pairs like that, but it can be a little bit difficult to keep track of exactly where all the information is, an important piece of information. So we can list this in a few different ways. One is just as a table where we put a nice line down the middle, a little line across, and we indicate that our first coordinate will be on the left, our second on the right, and we list each time the first one, my input is X, my output is Y. So this is 2, 3. Color code that here. And then we could do our 2, 5. And we typically want to do this in order by our X coordinates. So if my next one here is 3, 5, oops, that in black. Okay, and then we'll do 3, 8, and 4, 7, and 6, 10. Hopefully you wrote a little smaller than I did, but that would be representing our data as a table. You'll often see this table enclosed like this. It's the same either way, whether you enclose the table or not. Okay? And then we could also represent these points on a graph. So if we have a graph, we can plot these points, and we'll need to have an X of, let's see here, a Y of up to 10. So I'm going to move this line down so we have a little more room here. Right, and this is just going to be roughly drawn, but 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my first point is 2, 3. That means over 2, or right 2, up 3. Right 2, up 3, so right here. This is my point 2, 3. Right? Then we have this point 2, 5. That means right 2, up 5. So right 2, up 1, 2, 3, 4, 5. And my point 2, 5. Here's our 2, 5 point. Okay. Then we have our point 3, 5. That's right 3, up 5. 1, 2, 3, up 1, 2, 3, 4, 5. 3, 5. Okay, I'll put that in green. Okay, and we have a point 3, 8. That's right 3, up 8. Right 3, up 1, 2, 3, 4, 5, 6, 7, 8. You see it has the Y coordinate of 8. 3, 8 here. And we have the point 4, 7. Right 4, up 7. 2, 3, 1, 2, 3, 4. The X coordinate of 4, Y coordinate of 7 here. 4, 7. See, Y coordinate of 7 there. Okay. And finally we have 6, 10. 4, 5, 6, 8, 9, 10. 6. I just wanted to do that in green. 10. All right. So that is another way that we can represent. We can kind of see these values visually and how close they are to each other. And then finally, we can also view these values as a mapping. So in a mapping, we write two kind of rectangles, or I often see them as these kind of like soft, fun shapes here. You can kind of have fun with it there. And the one on the left, we label our domain. And the one on the right, we label our range. And what's unique about writing this as a mapping is we will write each input value only once and each output value only once. So what I mean by that is, for instance, we had, for our first point, we had 2 and 3. So we put in a 2 and we got out a 3. And then we connect these with a line showing the relationship between 2 and 3. But then when we go to do this point 2, 5, we don't write the 2 a second time. We keep that same 2. We write the 5, and we connect those. And this shows me that when I put in a 2, I could get out a 3, or I could get out a 5. So this can be a really useful way to view our information. Then we also have that if I put in a 3, I could also get out a 5. Notice I don't draw the 5 again. It just goes to the 5 that I already have drawn. Then I also have that 3 could go to an 8. And I have that 4 could give me 7. And that 6 could give me 10. So this helps me see that 4 only goes to 7, 7 only comes from 4, 6 only goes to 10, 10 only comes from 6. But 3 as an input can result in 5 or 8. And 2 as an input can result in 3 or 5. I can only get 3 from 2, but I could get 5 from 2 or 3. I can only get 8 from 3. So these are some ways of kind of reading mapping. All right? So let's practice this. We're given a row of data points, and we're going to write this as a table, a graph, and a mapping. So as a table, this is maybe the easiest. Again, remember we want to put these in order by x. So I'm going to start with my lowest value of x. That's this one, -2, 3. My next lowest is here, -1, -2. Next lowest is here, 2, 5. And my last 5, -2. So that's my table. X, Y. All right? And then plotting these as a graph. All right? Now I know my highest Y value is 5 and my highest X value is 5, so I want to make sure I can at least go that far. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my first point is -2, 3. That -2 means left 2, +3 means up. So -2, +3 is right here. All right? And I have -1, that's again left. -2, that's down. -1, -2, right here. Okay? 2, +2, that's right. +5, that's up. So 2 to the right, 5 up. That's this point here. Then +5, that's right. -2 is down. +5, -2, right here. So these are my plotted points. And as a good practice, we should always label our coordinates. This one's -2, 3. This one is 2, 5. This is 5, -2. And this was -1, -2. All right, so we've represented these as a graph. And then as a mapping, that's our little squiggly lungs or kidneys, domain, and a range. And remember, we never want to duplicate anything on either side. So I have a -2x, gives me a 3, and I connect them with my line. A -1 gives me a -2, so I'm going to connect that. A 2, and in fact, I kind of want to list the y's in order as well. So let's list all our values: -2, -1, 2, and 5. And then my y's, my lowest y is -2, then 3, then 5. Right? Then I connect them. -2 gave me 3, -1 gave me -2. 2 gave me 5. And 5 gave me -2. It's like the world's easiest matching game. All right, and so that is representing as a mapping. And that is representing a set of pairs, ordered pairs, as tables, graphs, or mappings.